Arranging and comparing decimals. Inequality symbols. We use the inequality symbols, less than and greater than, to show which number is greater. On the left we have A is greater than B, and on the right there we have A is less than B. Here's some examples. 12 is greater than 5. That's the first line. The second line is 8 is less than 13. Notice that the inequality symbol opens up to the larger number, and it also points to the smaller number. So when we wrote 12 is greater than 5, it opens up towards 12, and it points towards the 5. It points towards the smaller number, and opens up to the larger number. Okay, to determine which of two decimals is greater, first of all, if the whole numbers to the left of the decimal point are different, first, compare the whole numbers to the left of the decimal point. If the numbers are not the same, the larger decimal number is the one with the larger whole number. The smaller decimal number is the one with the smaller whole number. So figuring out which one is larger, look at the whole numbers. The one that has the larger whole number is the larger value. The one that has a smaller whole number is the smaller value. Example 1. Write an inequality symbol between the following numbers. So 15.27 and 32.7. So look at the whole numbers in front of the decimal point, to the left of the decimal point. Which one is larger, the 32 or the 15? Yes, the 32 is larger. So you don't have to look at the decimals. You don't have to look at the numbers to the right of the decimal point. Just the numbers to the left. So it would open up towards the larger number. It points towards the smaller number. Okay, let's do the next one. Which one has a larger whole number? 43 does, right? 43 is greater than 8, so it's going to open up to the number on the left. Okay, let's try one more. Again, write an inequality symbol between the following numbers. It opens up towards a larger number, and it points towards the smaller number. So for A, it opens up to the 104, because 104 is greater than 18. And then B, which is larger, the one on the left or on the right? Right, the one on the left. Now, if the whole numbers to the left of the decimal point are the same, well, then we have a different procedure. Okay, so the whole numbers to the left of the decimal point are equal. We compare the digits to the right of the decimal point to determine which is larger or smaller. We compare the numbers by starting with the first place value, the tens place. The number which has a larger digit in the tens place is a larger number. If the digits in each number in the tens place are also equal, we then move on to the next place value on the right, which is the hundredths place. Again, the number which has a larger digit in the hundredths place is a larger number. If the hundredths place are equal again, we then move on to the thousands place to determine which is larger. We continue this process until the number that's larger is identified. So we go to each place value. We go to the tenths to see which is larger. If they're the same, then we go on to the next one on the right, the hundredths. If those are the same, we go to the thousandths. So the first number that has the larger place value, that's our larger number. Okay, let's try some examples. Okay, write the inequality symbol between the following numbers. 6.2 and 6.5. So the whole numbers are the same. They both have a 6 in front of the decimal point. So we're going to look at the tens place. Whichever one is larger, that's the larger value. So which one is larger, the 2 or the 5? Right, the 5 is. So the larger number would be 6.5. It always opens up to the larger number. Okay, let's look at part B now. The whole numbers are the same. They both have a 17 in front of the decimal point. Now look at the tens place. Which one's larger? Well, actually they're both the same, right? So now we'll move on to the hundredths place. That's the second number after the decimal point. Which one is larger? The 7 is. So the number on the right, 17.872, that's our larger number. Okay, 2 more here. You could always pause the video and work these out on your own, and then click on play when you're ready to continue. Okay, so 0.247 and 0.28, which one's larger? Right, the 28, because in the tenths place they both have a 2, and then in the hundredths place, the first one on the left has a 4, and the second one has an 8. So the 28 is larger. So sometimes people will make a mistake and say, oh, 247 is larger than 28. But remember, we go by place value. We go by place value. So the 0.28 is larger. Okay, 0.563 and 0.560. The tenths place is the same. The hundredths place is the same. So then we move on to the thousandths place. Since 3 is larger than 0, the number on the left is larger. Okay. A couple more problems. 0.92 and 0.923. The tenths place is the same. The hundredths place is the same. But the thousandths, well, you could always think of it as if there's a 0 in the thousandths place on the first number because there is no number. So the first number is 920 and the second one is 923. So which one is larger? Right, the number on the right. Okay, in part B, 0.4, that one has a bar over it. Recall that that means that it's a repeating digit. The 4 continues on and on. So if we write that out, it means 0.444, etc. So which one is larger? Actually, that number is larger because in the hundredths place it has a 4, and the number on the right, in the hundredths place there is no number, so it's a 0. The number on the left is larger. Okay, here we have some fractions in this next problem. 0.38 and 3/8. Well, in order to determine which one is larger, we're going to have to change that fraction into a decimal. How do we change a fraction into a decimal? By dividing the denominator into the numerator. So go ahead and divide 8 into 3. You might want to pause and work on it. Okay, 8 into 3. Bring your decimal point straight up. Remember, the decimal point is after the last number. So after a 3, we can put the decimal point. Bring the decimal point straight up. So 8 into 30 goes 3 times. 8 into 60 goes 7 times. And 8 times 5 is 40. So the number on the right is 0.375. Now we can determine which number is larger. And that would be the number on the left, because 8 is larger than 5. They both have a 3 in the tens place. Okay, go ahead and change 7/11ths into a decimal. So bring your decimal point straight up. 11 into 70 is 6 times. 11 into 40 is 3 times. And it's going to keep going in that same pattern. 6, 3, 6, 3. Okay. You could put the bar over it. You don't have to. You could just write 0.6363. But now we know which number is larger. That one again is because the number on the right, the last digit is the hundredths place, which is a 3. The hundredths place on the number on the left is also a 3. But then to the right of that 3 on the fraction, it keeps going on in that same pattern. So since that has a 6 and the number on the right has a 0, then the number on the left is larger. Okay. Arranging decimals from least to greatest. Comparing decimals will serve us in arranging decimals from least to greatest. First, identify the smallest value by using the same techniques we have previously learned. Then, from the remaining numbers, identify the next smallest number. Continue this process until the last number remaining is the largest number. Okay, so arrange the following decimals from least to greatest. Well, which number is the smallest? Let's look at the whole number. Looking at the whole numbers in front of the decimal point, 1.5 is the smallest, since it has the smallest whole number. So we'll list that number first. Now we'll look at the next smallest number. What's the next smallest number after 1.5? Which one has the smallest whole number? Well, there's two numbers that have a 2 in the whole number position, in the ones place. This is 2.7 and 2.2. Which of those is the smallest number? Well, we look at the tens place, and 2.2 would be the next smallest number, because 2 is smaller than 7. Then the next number would be 2.7. What's our next smallest number in the whole number position? In the ones place? That would be the 4, 4.3. And then the largest would be 6.4. So we have arranged our numbers from smallest to largest, or from least to greatest. Okay, let's do one more problem, and then that'll be it for this video. You might want to pause it and arrange the numbers, and then click on play to see it worked out. Okay, looking at the tens place. Now in the ones place, they're all zeros, so that's why we're going right to the tens. Look at the one that has the smallest tens place. The first number is an 8, second number is a 3, third number is a 9, fourth number is an 8, and the fifth number is a 3. So the two numbers with the smallest tens place is a 3. So which one's the smallest? Right, 0.3. So the next smallest would be 0.37. Okay, now which number has the smallest tens place? Well, there's two numbers with an 8, 847 and 863. So 847 would be the next smallest number. and 863 would be the next smallest. And the largest number would be the one with the 9 in the 10th place. And that's really all there is to these kind of problems. If you have fractions at any point, you would have to change them to decimals first. So just be aware of that. Any fractions must first be changed to decimals in order to determine which number is larger or smaller. Okay, so that's it for this video. Have a good day.